Hello everyone, and today we are going to cover what is NAT and why you need it, what kind of different scenarios are there, like for example static, dynamic or PAT and overload, in what cases you will be using it, and at the end we will be doing a quick lab. Feel free to skip the section which you are aware, I already added the timestamps. Those who don't know me, my name is Vakas and I will be covering CCNA, NP and IE. Please hit like and subscribe and hit the bell icon so you can be notified for the upcoming videos. Let's get started. The first thing we are going to understand is what is NAT and why you need it. In IPv4, we have limited IP addresses. You know that we cannot use the public IP addresses in private range. The reason is simple. The IP address needs to be unique on the network. And we don't have enough IP addresses pool in IPv4 to allocate to all the devices which are running on the network. So what is the other methods we have? The method we have is we need to route the private IP addresses on the public domain using a technology which is named as network address translation. What this technology does is it takes that private IP addresses and translate it to the public IP addresses. The possibility is it's a static, that one-to-one. This scenario is mostly used in where you are running the servers and you want the public to access your servers. It could be dynamic. That is mostly used in the enterprise section where a lot of users are using and you have a pool of public IP addresses. The third is PAT, or is sometimes named as PAT overload or NAT overload. Its same names is just think it in a way that it's a PAT. It's port address translation. In this one, we are taking all the hosts internal to the network and converting them to single IP address or single interface IP address. Let's take an example of a NAT. In this example, we have the user and we have a web server where a website is running, for example, google.com. In this example, the user tries to reach google.com, which is available on the public address, but you are on the inside of your network. Your IP address, let's say 172.16.1.254. It's a private range. You cannot route it over the internet because everyone will be using it all across the world. So what we will be doing is we will use your private IP address and translate it to public IP address in three different manners. That is, it could be static, it could be dynamic, or it could be PAT address. So in this case, what will happen is your source packet will change. In the header, you will be always having source and destination fields, right? When this packet will reach to the router and the router tries to send out, what will happen after the NAT is your source will be changed. Your source will become the NAT address. Since NAT address is public IP address, what will happen is the destination server will send the reply to the router interface IP address or router interface pool IP addresses where you have configured the NAT. There might be a question that can NAT be only used for private to public translation? No, you can use it for private to private. It can be used internally. It can be used for external. It can be used for web servers. It can be used for one-way communication as well. So in many cases, we can use this NAT to achieve the design what we want to. The first example we are going to discuss is static NAT. In static NAT, remember the difference. What is the difference between all these three different types is static NATs offer you two-way communication, that the source can communicate with the destination, as well as if someone is outside your network, he can even initiate the communication from their side. So this is a two-way of communication. You can also initiate the connection and the other side of the device can also initiate the connection. In NAT, we have two simple steps. One is we will be mentioning which interface is inside and which interface is outside. And based on this one, we will select the scenario which best suits our need and we can configure the NAT. In our example, we will configure IP NAT inside, which is going to be fast Ethernet 0/0. It's our inside interface. And we have the other side of the interface, which is outside. We will be using it as IP NAT outside. In NAT language, there are few terms which you should be aware. Inside local and inside global. What is the difference between these two is inside local means IP addresses which are going to be part of inside interface, the interface which is connecting to that. So the traffic is going to come from that interface. Inside global means the IP address which will be translated on that one, that IP address will be inside global. It could be a pool of IP addresses, it could be a single IP address, it could be even PAT scenario as well. So any of the scenario can be there. In our example, we have a single web server communication. So what will happen is we will use the static NAT, and what we will be doing is configure the step 2. So the step 2 we are going to do is we will be configuring IP NAT inside, that's the source of that traffic. Inside source, what is the source type, and we will be using static because we are going to configure the static NAT. Then we will be mentioning what will be this inside local IP address. Inside local IP address, as I mentioned, it's going to be inside of the router. So we will be using that IP address 172.16.1.254 outside IP address or inside global. In this IP address is going to be the IP address where the inside IP address will be translated. That IP address we want to assign it 150.1.1.10, that's the public IP address, we can assign it. And this is how we configure static NAT. It's very simple. You just be aware with very important concepts of NAT and the steps of it, you should be fine. Static NAT offers bidirectional communication, both of the source and even the destination side of it. You can initiate the connection to the source, but in other traffics we will just look in what is the other differences, and you will be mentioning one-to-one NAT. Static NAT is also one-to-one, just remember it. You will have one host translated to one IP address. Hope that clarifies static NAT. The next one we are going to understand is dynamic NAT. Dynamic NAT, in this one the difference between static and dynamic is you will be having pool of public IP addresses where you want multiple source machines to get translated to the public IP addresses. In this one you can have 1, 2, 10, 50, as many as public IP addresses you want. First IP address will utilize the first IP address from the pool and get translated. This is not a permanent connection. As far as the IP address translation is there, you will be able to reach and you will be able to reply back to the machine. But once the entry is expired, you will not be able to reach the source. So the new connection needs to be initiated from source side. This is what happens in dynamic NAT. Let's take an example. We have two machines, 172.16.1.254 and .251. In this one, let's say 251 wants to go to google.com. What will happen is 251.1 will be translated to public IP address 150.1.1. We have 11, first one, it will take that IP address. The second one, when 254 wants to go out, it will take .12. So this is how the dynamic NAT works. In dynamic NAT, the major difference is you can translate multiple IP addresses to a pool of IP addresses, and once the NAT is expired, it can be used for next IP address as well. What is the steps of configuring the dynamic NAT? It's similar to static NAT. The difference is in this one we are configuring the pool of IP addresses on the public side. In static we was having one-to-one mapping. In this one the step 1 stays as it is. We are just mentioning inside local and outside interfaces or inside global interface. We are just highlighting that. That's step 1. That's gonna stay same. Step 2, we will be configuring access list. Who will be the source? This source can be host IP addresses. It can be whole network. So we will configure that access list. In step 3, we are going to configure the pool. That pool is what? How many public IP addresses you have from the internet. That will be this pool. Let's say IP NAT pool, and the next one is pool name, and you will be mentioning first IP address and the next IP address, and after that one you will be mentioning what will be the net mask for that. If you don't know what is the subnet mask, net mask, network IDs, the link is above, just check the lecture. The step 4 we are going to do is we will be applying the NAT. IP NAT inside, since we already mentioned inside local and inside global IP interfaces, so now we can just highlight IP NAT inside source here we are mentioning is gonna be list, and we match that specific access list. It could be standard, extended, and we will be mentioning what will be the pool on the inside global side or outside interface. What will be the pool of IP addresses which needs to be used? That one will be named as, we already named it IP shuttle. We will use that as our pool. This is how we configure dynamic NAT. In this one, the source will be taking the first IP address and go out. The next comes, it will take the second IP address, goes out. By this way, you will keep continuing using it until you exhaust the pool. And once the entry is expired, it's available for the next device to use again. That is what happens in dynamic NAT. Hope that clarifies. The next one is PAT, port address translation, or it's also sometimes named as overload. In overload, what happens is, overload is a term where it refers to that all the IP addresses which are inside local will be translated to single IP address until the port numbers gets exhausted. I'm sure it's a little confusing, but just hold on for a second. I will be explaining that. For example, we have the source, same 172.16.1.254 and 254. We have the two source. What is going to happen in the scenario of overload? Once 172.16.1.254 wants to go out, it will keep an entry of what is the source port of that and keeps allocating the ports starting from above 1000 till 65535, and it will keep assigning the ports until it runs out all the connections. For example, inside of the network you have maybe 4000 hosts. How many connections you can create on single IP address? It will keep continuing assigning ports from 65,000 range and until it completely exhausts all the port numbers. So you will be able, technically you can have up to 65,535 minus 1000, approximately that much host, but ideally we don't configure more than 4000, so that just to keep everything under control. It will be maintaining the list of those port IDs, and whoever is requesting that NAT, it will be able to revert back the packets once it's received from the destination side. That is what happens in the PAT. There are two ways to use the PAT. One is you can translate to a pool of IP addresses similar to dynamic, but the difference between dynamic is it's gonna use one-to-one mapping. In once you configure overload term in front of that command, which we have already seen in dynamic configuration, it will be able to convert it to a pool of IP addresses available for doing the PAT. One IP address converted to the inside global IP address, then it will be assigned a port number in front, which it will maintain the list, and it will be able to identify what is the difference between different IDs which are coming in. And until it does not exhaust all the ports, it will be continuing using that same IP address. Once that exhausted, it will start using the next IP address. In terms of configuration, let's quickly look into both of the examples what we have just now discussed. Step 1 stays same, step 2 stays same. We have no difference. We are just configuring the list. In step 3, what is the difference is we have the pool similar to dynamic, and the last part is we are mentioning overload term in front. So once you mention the overload command in front of that pool, what's going to happen is these 10 IP addresses now can be used by multiple hosts from the inside network. For example, inside network you have maybe 10 networks. In step 2, you have already configured how many networks are there. All these networks will be now translated to these 10 IP addresses. Once the one IP is exhausted, it will just move to the other one, keeps assigning it. In dynamic, you was only able to utilize for 10 devices. Now you are able to utilize for virtually a lot of devices. This is what happens in overload case when you have multiple IP addresses in the pool. In case you don't have the public IP addresses available, you have only one IP address which is assigned to the interface. What's going to happen is you will be mentioning what will be the interface ID, and it will do the rest. It will just take the inside local machines and translate all of them on single interface. Now all of the machines which are available internally, they will all be translated to the external IP address which is configured on the interface. In other cases, you can assign a pool, and that is not necessarily that it should be having the IP address from that interface. As far as it is from the range and you have available public IP addresses other than the interface assigned IP address, you should be fine. The only difference going to be in the configuration is you will be mentioning in the step 3, you will be mentioning IP NAT inside source list network or host IP addresses, and mention interface. What will be the interface? And after that one, just write the command overload and it should do the PAT over that interface now. Hope that clarifies all the information. Now let's quickly do the labs for static NAT, dynamic and PAT, and we will see how this works. This is gonna be our lab. In this lab, what I have did is I have already configured the IP addresses on the machines, and I have added one web server which we will try to access it from the source machines on the left, which is 172.16.1.251 and 254. These machines we want to access the web server from. So what's going to happen in this one is we will configure one static NAT for the web server, which will be a perfect use case for day-to-day life, because when you will be working in the enterprise networks, you need to do NAT for the servers. You will know how to do that. And from the source side, we will practice static NAT, dynamic, and we will also practice PAT. For the server, you cannot use dynamic and PAT. The reason is very simple. Because you will be translating all of the IP addresses on that one, how someone will identify that there is a connection going to be inside. And it does not allow the connections to be established from outside to inside if there is no NAT entry is available. So let's go back and let's configure the static NAT, one for the server, which will be this web server, on R2, and one static NAT we are going to configure on R1. Let's finish the static NAT on R2. Let's go over to the R2. Let's go to the R2. The first step is we need to mention which interfaces are going to be inside local and inside global. Let's quickly do that. Do show IP interface brief. And we have two interfaces. One is connected to the inside server and one is to the outside public IP address. Let's configure it. Giga Ethernet 0/0/0. This is going to be our inside local IP address. So IP NAT inside. Very simple. The next one, interface Giga Ethernet 0/0/1 IP NAT outside. So this is going to be our inside global IP address or global interface basically. The next thing we are going to do is very simple, IP NAT. All right, and we are going to mention what will be the source. We are going to assign single source. We are going to assign then like a list. It depends. We are configuring a static NAT, so we want it static. Here, if you notice, we can do the port forwarding as well. We will see how to do that. But for current, we are going to look into single IP address to single IP address translation. We want it to translate 192.168.2.254. We want to translate it to 150.1.1.100. All right. So that's how we configure the static NAT. It's very simple. Now if you do show IP NAT translation, we have one static entry, but we don't have any connections to it. Now if we go to R1, we should be able to ping it, because even we don't have route for the 192.168, we should be still be able to ping it. We have already created the NAT. Let's do show IP route. And if you notice, we don't have any entry for 192 network. We don't have any default routes configured. Let's do a ping from here, 192.168.2.254. See, we are not able to ping it. But if you try to ping 150.1.1.100, you should be able to ping it. Because it is on the outside interface IP address, it will just broadcast on that one and tries to resolve the ARP. ARP is received, it should be able to ping it. Let's try it. 151.1.100, and we are able to ping it. If we are able to ping it, we should be able to browse it as well. All right, just hold on. We are going to configure the static NAT for inside network on this one, and we will try to browse it over the web interface. So let's go to PC1 and let's quickly look into the configuration what I have already did on that. I just configured IP address on this one and I have a default gateway on this. Let's check, can we reach the destination IP addresses or no. Let's go to 1 and all right. And let's try ping 192.168.2.254. All right, destination host unreachable because our default gateway does not have the route. But can we ping 150.1.100? Let's try that. Ping 151.1.100. Our gateway was able to reach it, but the other side of the network does not have the route back to this one. So here we are going to use the static NAT to do our stuff. So we will do one thing is we will translate the internal IP address to one of the public IP address on the external side, and we should be able to browse the internet. Let's go to R1 and configure GigaEthernet 0/0/0/0 IPNet inside. Interface GigaEthernet 0/0/1 IPNet outside. We have configured inside local and inside global interfaces. Now let's configure IPNet inside source static. We want it static 172.168.1.254. I want to translate it to inside global IP address 150.1.1. maybe 10. Let's use that 151.1.10. And if you go back and show IPNet translation, we have one static entry and show IP NAT statistics, and we have one entry here as well. So let's go back to PC1 and try to ping that same IP address again. We have the reply. What is happening is the inside IP address now is getting translated on the outside public IP address. We have already highlighted show IP NAT translations. And if you see, there are entries for the NAT translation. What is it says? What is your inside global IP address? What is the local and what kind of protocol it is and where it's trying to reach. So everything is mentioned in this table. That's how we do static NAT. Hope that clarifies. Let's quickly do the dynamic NAT and PAT and finish the labs. In dynamic NAT, what happens is we will be using is pool of public IP addresses starting from 150.1.1.11 till 20, and we will try to ping from both of the machines and we will see the NAT entries, and even we will try to browse in this example. We did not browse in our previous example. So what was going to happen is the destination we will leave as it is. We are going to need the static NAT. We will leave as it is. We have already configured in the previous step. Let's go to R1. We already have our inside local and inside global interfaces. Let's quickly check it, show on, and go to the interfaces. And you should be able to see IPNAT inside and IPNAT outside. So step 1, we are done. What is step 2? We are going to mention who will be the source. We will configure the access list. If you're not aware how to configure the access list and all those things, the lecture is above. Just check it. Let's configure one access list, IP access list standard. All right, let's name it PC1 to 2. All right, and permit host 172.1.254, and we have one more IP address 251. So we have two IP addresses. We already configured it. Now what we will need is step 3, IP NAT. All right, we will be needing pool. Here we will be configuring the pool name. I will be naming it IP shuttle. If you notice here, we need to mention start IP, end IP. We will just configure a pool of IP addresses 150.1.1.11 till this is the end IP address 150.1.1.20. We want it till here, and it will be asking you what is the subnet mask of that. 255.255.255.0. This is /24 IP addresses, and in public ranges they mostly assign /29/30. So whatever your net mask is, just configure it for the IP addresses and it should be fine. Let's quickly do the last step of our dynamic NAT, IPNAT, inside source. Here we're going to mention what is the list, PC1 to 2, we have already configured it. And here we're going to mention what will be the pool. We have named it IP shuttle. And if we do show IPNAT translation, everything is empty. Let's go back to PC1 and tries to initiate this translation. If you do that, it's pinging. Let's go back to R1 and let's see if there are any entries. Okay, and if you do up arrow, it has initiated the NAT entries. For that one, you see 4 entries since it sent the packets, and you see that one. And but notice here one thing, you have inside local 172.16.1.254 and inside local you have 11. We have the pool from 11 to 20. If we just go back to PC2 and try to initiate the connection from there, we should be able to run and we should be able to initiate another connection. Let's go back and ping 151.1.100 and we are able to ping it since we have in our source list. If we go back to R1 and we do up arrow, all right, and you should notice this thing, our inside local and inside global IP addresses. Inside local is 172.16.1.251 and outside IP address now for after the NAT inside global it's 1.12. So it's gonna use one by one until it exhausts, and then the NAT entries will be expired. It will just start again and all those things. It will just keep doing that. That's how we do dynamic NAT. Let's quickly browse it from the source. If you go back to the interface for the web browser, let's go to the browser. And if we try to browse HTTPS 151.1.100, we should be having the website coming up. So that's how we reach the destination servers. Let's go back to PC1 and let's try to initiate both of the communication. For example, if I try to ping 150.1.1.2, I am able to reach it and even the web server. And if we go back to the desktop, we have the web browser and let's make the connection HTTPS 151.1.100. We are able to browse both of the things. What I want to show you is on R1, if you go back and do show IPNAT translation, you have the NAT entries for both of the types of protocol, ICMP and TCP. In this one, what's going to happen is these devices are able to reply until the initial connection is initiated. They will be able to reply back. Once the session gets terminated or the NAT entry is expired, there is no reply back. It will be getting discarded. And we can also find out this information under show IP NAT statistics. And if you notice here, we have 10 IP addresses and we have already used one out of that. And we have pool from 10 till 20, and this is the net mask, this is the pool used and everything. This whole information is available under show IP NAT statistics itself. The last part of the lecture is PAT or overload functionality. Let's quickly do that. What is the difference going to happen? As we highlighted, it will be utilizing it as a pool or it can be interface overload. Both of the functionalities are available. How to configure it? We can utilize the same pool. I will prefer we can configure the pool with one or two IP addresses, but we can utilize it. Let's quickly go to R1, show running. Let's go to the pool and find out what is the pool name is running and what is the NAT is running. So we have the NAT here. Let's copy this one. All right, let's go to configure terminal and let's do the no for this one. We want to delete this entry so that we can see the next entry, what we want to do, right? It's saying there are mappings available. How you can clear the mappings? Clear IP NAT translations with star, and you should see no entries. Show IP NAT translations. We have the empty translation table. We should be able to delete the entries now. No IP NAT inside source, so it's fine. Now let's reconfigure the same line. Let's paste it. And at the end of the line, if you notice, there is an overload word. If you utilize this one, okay, now what's going to happen is you can have maybe thousands of inside hosts. They can all utilize the same IP addressing pool. And let's go to show IP NAT statistics. And we should be able to see what is configured in this one. We have the source. All the interfaces are configured. NAT is there. NAT inside to outside, everything is there. So let's try to do the ICMP and HTTPS from PC1. Let's go to command terminal and let's try to ping 1.100 again, and we are able to ping. Let's try to browse. Okay, let's try to browse that. HTTPS 151.1.100. We are able to browse it. So that's mean our overload functionality is working. Let's quickly go to R1 and let's see show IP NAT. All right, let's quickly check show IP NAT translations. We have the NAT entries and we have the ports allocation properly. We have the TCP, ICMP, and everything is done. Now even multiple hosts keep coming. It will just keep assigning them the ports, IP addresses. Let's go to the other one and let's try to ping from here. All right, we are able to ping it. Let's go back to R1. Let's see if there is any difference. All right, if you notice here, there is one interesting thing happened. In 13, it used that one IP address and started assigning the ports at the end. If you notice here, we have our inside local IP addresses, two IP addresses here, 251 and 254, but they are all translated to same IP address on the outside. That is what overload does. In dynamic, what was happening is all of them was using one separate IP addresses, if you remember from show IP NAT translation. But in overload functionality, now they are continuously using one IP address until it's gonna get exhausted, and they all will then start using the next IP address. We have 10 IP addresses, but they are not using it still. So that is what happens when it is translated to the pool of IP addresses. The last part of it we want to do is we will just translate all of the internal IP addresses into the interface. That is also called as PAT, port address translation, or overload functionality, whichever you like. Feel free to utilize it. All right, so let's go back to R1. Okay, let's delete this pool. We will not need it anymore. Okay, it says the entries are there, clear IP NAT translations star. So it will just clear all those entries, whatever we have it, and let's do it again. How we configure that? IP NAT inside source list, PC1 to 2, same list which we have already created, the access list to match the source. Here if you do the question mark, you have two options. We will configure over the interface, and we just need to mention giga ethernet 0/0/ we want to translate it to inside global interface, and we will just mention overload it. All right, and we should see the same kind of response what we was expecting. Let's go back to PC1. Okay, and let's go to CMD. Let's try to ping it. We should be able to ping it. Yes, we are. Let's go back to 251 and let's try to ping from there as well. Yes, we are able to do that. Let's go to R1. Okay, let's do show IP NAT translations. We have the NAT entries with single IP address 150.1.1.1, which is our interface IP address, and is just using the port numbers at the end for the identification of it. It's gonna continue using it until it completely exhausts all the ports available which it can assign. These ports I'm referring to TCP ports. Basically what we say is starting from 1 till 65535. These are the ports available. Just read on these what are these ports numbers are and why we use it. This is how we configure PAT or PAT overload or interface overload, whichever you like. Okay, let's quickly run through one diagnostic. You can do debug IP NAT, all right, and just enter, and the debugging is on R1. Let's go back and let's try to ping it again. Okay, let's go back and let's try to ping. Let's go back to R1. You will see a beautiful response coming there. All right, so what happened is it has translated the NAT entries, but also it has printed the diagnostic information on the screen as well. For example, the source was this 172.16.1.254, and it is translated to 150.1.1.1. Destination was this. This is the ID they have assigned to it. If I have increased your knowledge in any ways, please hit like and subscribe and hit the bell icon so you can be notified for the upcoming videos. I will see you in the next lecture. Take care.